Hi students, I am continuing the chapter application of derivatives and today I am going to discuss some problems related to increasing or decreasing functions. So this is an important topic, so listen carefully. Hi students, this is our first question. Show that y equal to log of 1 plus x minus 2x divided by 2x plus x, where x greater than minus 1 is an increasing function of x throughout its domain. So let's start the solution of this question. Given that y equal to log of 1 plus x minus 2x divided by 2 plus x. So also given that the domain, here given that x greater than minus 1, I hope you remember the interval portions in class 11. So we need to convert this into the interval. We get it is x greater than minus 1 means the intervals is lies between minus 1 open interval minus 1 comma infinity. Okay. We know that if a function is said to be increasing function, their derivative, that means f dash of x should be greater than or equal to 0. Okay. So let's start the solution of this question. Here, first of all, let it name it as equation number 1. Okay, so first differentiate equation number 1 with respect to x on both sides. On LHS, we get dy by dx equal to, derivative of y is dy by dx equal to derivative of log 1 plus x. We know that the standard derivative of log x is 1 by x, but here we need to find the derivative of log 1 plus x. So if derivative of log x is 1 by x, then derivative of log 1 plus x become 1 divided by 1 plus x. Replacing this x by 1 plus x, we get the derivative of log 1 plus x by 1 divided by 1 plus x. And again 1 plus x is another function, so we need to calculate the derivative of 1 plus x also using chain rule. Okay, minus, next we need to find the derivative of 2x divided by 1 plus x, derivative of 2x divided by 2 plus x. Here I am going to use the derivative of u by v form or a quotient rule. U by v whole dash is equal to, we know that the quotient rule is, what is the quotient rule? V into u dash minus u into v dash whole divided by v square. Here u is 2x and v is 2 plus x. So substituting this value, we get our dy by dx is equal to 1 divided by 1 plus x into derivative of 1 is a constant, right? So we know that the derivative of a constant is 0, so derivative of 1 is 0 and derivative of x is 1. Okay, minus, here I am going to use the quotient rule. So we get 2 plus x into denominator into derivative of numerator, that means derivative of numerator minus numerator into derivative of denominator whole divided by denominator square, that is 2 plus x whole square. which will be equal to 1 divided by 1 plus x minus 2 plus x into derivative of 2x. 2 is a constant and derivative of x is 1 minus 2x into derivative of 2 plus x. Derivative of 2 is a constant, so derivative of 2 is equal to 0 and derivative of x is 1. So here we get 1 only, whole divided by 2 plus x whole square equal to 1 divided by 1 plus x minus opening this bracket, we get 4 plus 2x minus 2x whole divided by 2 plus x whole square. And these 2 plus 2x and minus 2x will cancel each other and we get 1 divided by 1 plus x minus 4 divided by 2 plus x whole square. Okay. So next I am going to cross multiply this we get 2 plus x whole square minus 4 into 1 plus x whole divided by 1 plus x into 2 plus x the whole square. Okay. What is the expansion of a plus b whole square? We know that the a plus b whole square is a square plus 2ab plus b square. So I am going to use this identity by expanding 2 plus x whole square. Okay. So 2 plus x whole square means, using this identity, we get 2 square plus 2 into 2 into x plus x square, that is 4 plus 4x plus x square. Okay. Next I am going to substitute this answer. Here we get 4 plus 4x plus x square minus 4 minus into plus means minus. So it will become minus 4x here whole divided by 1 plus x into 2 plus x the whole square. And if you observe this term, we can see that this 4x and positive 4x and negative 4x will cancel each other, and also this minus 4 and plus 4 will cancel. Okay. So the remaining terms are x square divided by 1 plus x into 2 plus x the whole square. Okay. From this we get our derivative of given function dy by dx equal to x square divided by 1 plus x into 2 plus x the whole square. Okay. So in this question here we need to show that our function is an increasing function. We know that if a function is to be increasing function, the derivative of function is greater than or equal to 0. Okay. If a function is said to be increasing function, the derivative of function should be greater than or equal to 0. So, in this step, we get our derivative of x, and if we say that our derivative of function dy by dx is an increasing function, it must be greater than or equal to 0. Okay. So I am going to substitute the value of dy by dx here. We get x square divided by 1 plus x into 2 plus x the whole square should be greater than or equal to 0. Okay. We know that the numerator part, we know that any number, square of a number, any square of a number is always greater than 0. Right? Similarly, 2 plus x the whole square. That means we need to here a squared number is always greater than 0. Okay. So we get x square is always greater than 0 and 2 plus x all square is always greater than 0. That means it should not be negative. If we observe this derivative, if this derivative should be greater than or equal to 0, here x square is always greater than 0. Similarly, 2 plus x all square is always greater than 0. Any square number, it should not be negative. It's always positive or equal to 0. Right? But if you observe this derivative, these two things are x square and 2 plus x the whole square are positive. All positive. The only thing is 1 plus x. We need to check 1 plus x is positive or not to become the whole derivative greater than or equal to 0. Okay. So, for our derivative x square divided by 1 plus x into 2 plus x the whole square greater than or equal to 0, 1 plus x 0 is an increasing function. Or greater than or equal to 0. 1 plus x should be greater than 0. It cannot be negative. Okay. So the only we can notice that this term 1 plus x is greater than 0. It should be greater than 0. That's why the whole derivative will become greater than 0, greater than or equal to 0, or we can say that our function or derivative of function is increased, greater than or equal to 0, or our function is increasing function. Okay. So if 1 plus x greater than 0, that means x, I'm taking this 1 to RHS, we get x greater than minus 1. X greater than minus 1 is the given domain. Right. So, that's what we have showed, that our function is increasing function of x throughout its domain. Okay. I hope you understood. This is our second question. Prove that y equal to 4 sin theta divided by 2 plus cos theta minus theta is an increasing function of theta in closed interval 0, pi by 2. So, let's start the solution of this question. Given that y equal to 4 sin theta divided by 2 plus cos theta minus theta. In this question, we need to show that the given function is an increasing function. We know that for a function is said to be increasing function, if f dash of x should be greater than or equal to 0. Right? So, let us name it as equation number 1. Here, note that here y is a function of theta. So, I am going to differentiate equation number 1 with respect to theta, not x. Because here y is a function of theta, not a function of x. So, note that differentiate this equation number 1 with respect to theta. Okay. So, we get dy by d theta equal to We know that here it is a form of u by v. So here we need to use quotient rule. We know that quotient rule is u by v whole dash equal to v into u dash minus u into v dash whole divided by v square. Okay, here u is our numerator and v is our denominator. So I'm going to apply this quotient rule here. We get 2 plus cos theta denominator into derivative of numerator minus numerator into derivative of denominator whole divided by denominator whole square. Okay, minus theta. Here again we need to find the derivative of theta. So I'm going to write the derivative of theta. We know that the standard derivative of x is 1. So here differentiating with respect to theta, that means here d theta by d theta means d by d theta of theta is also equal to 1. Okay, so applying these all result, we get our dy by d theta will be 2 plus cos theta into derivative of 4 sin theta. 4 is a constant and we know that derivative of sin theta, sin x is cos x. But here we need to find the derivative of d by d theta of sin theta. That means here is cos theta. Okay, minus 4 sin theta into derivative of 2. 2 is a constant, so derivative of a constant is 0. And next is derivative of cos theta. Derivative of cos theta is minus sin theta. Okay, whole divided by 2 plus cos theta whole square minus d theta by d theta is 1. Okay, next step, opening this bracket, we get 4 into 2, 8 cos theta plus 4 cos square theta. This minus and minus will become positive, and 4 sin square theta whole divided by 2 plus cos theta the whole square minus 1. Okay, so if we observe this quantity, we can see that here 4 is common. So next I am going to take 4 from all these term. We get 4 into 2 cos theta plus cos square theta plus sin square theta. Okay, whole divided by 2 plus cos theta the whole square minus 1. And we know that the identity cos square theta plus sin square theta is equal to 1, right? So I'm replacing this by 1. We get 4 into 2 cos theta plus 1 whole divided by 2 plus cos theta the whole square minus 1. Next I am going to cross multiplying this. We get 4 into 2 cos theta plus 1 minus 2 plus cos theta the whole square whole divided by 2 plus cos theta whole square equal to 4 into, I'm going to open this bracket, we get 8 cos theta plus 4 minus expanding 2 plus cos theta whole square by using a plus b whole square. We know that a plus b whole square is a square plus 2ab plus b square, right? So here we get 4. Don't forget to write this bracket because negative is here. So 4 plus 2 into 2, 8, 2 into 2, 4 cos theta plus cos square theta whole divided by 2 plus cos theta the whole square. Okay, and which will be further equal to 8 cos theta plus 4. After opening this bracket, we get minus 4 cos theta minus cos square theta whole divided by 2 plus cos theta the whole square. And if you observe this quantity, we can see that this plus 4 and minus 4 will cancel each other, and 8 cos theta minus 4 cos theta will become 4 cos theta. 4 cos theta. The remaining terms is minus cos square theta divided by 2 plus cos theta the whole square. Taking cos theta from numerator, we get cos theta into 4 minus cos theta whole divided by 2 plus cos theta the whole square. Okay. In this question, we need to show that our given function is an increasing function. So, we have to find out our f dash of x should be greater than or equal to 0. Right. And also we need to find out the given function is increasing function of theta in 0, closed interval 0, pi by 2. So, it depends on our theta, right? So, to find the value of theta for which our function f of theta is increasing function, put f dash of theta greater than or equal to 0. Okay. So, this is our f dash of theta or dy by d theta. We know that derivative of y can also be written as dy by d theta or f dash of theta. So, I am replacing this f dash of theta by cos theta into 4 minus cos theta whole divided by 2 plus cos theta the whole square greater than or equal to 0. Okay. For a function to be increasing function, it should be the derivative of that function should be greater than or equal to 0. So, if you observe this term, we can see that this square term. Okay, and we know that something square will always be positive, right? So, this term is always positive. 2 plus cos theta the whole square is positive, that means greater than 0. It cannot be negative. Okay. Next term is 4 minus cos theta. This term can never be negative. We know that the maximum value of cos theta is 1. So, substituting this 4 cos theta 1 here, 4 minus 1 is equal to 3, right? So, it should be, it is always positive. Okay. So, these two terms, we get these two terms are positive. The last term is cos theta, right? If cos theta is positive, the whole derivative is, we can say that the whole derivative should be greater than or equal to 0. if cos theta will be negative, this full become negative. Okay, so we can say that our cos theta should be greater than or equal to 0 if the derivative of our function should be greater than or equal to 0, or our given function should be an increasing function. Okay, so we can write it as cos theta should be greater than or equal to 0. That means we know that we have 4 quadrants. The quadrant which cos theta is positive are first quadrant and fourth quadrant. Right. First quadrant means it's the theta lies between, angle lies between 0 and pi by 2. And fourth quadrant means theta lies between 3 pi by 2 to 2 pi. Okay. So, but here we need in this question we need only to check our function should be increasing function if theta lies between 0 to pi by 2. So from this we get our cos theta should be greater than or equal to 0 if our theta is an element of closed interval 0 to pi by 2, or first quadrant or fourth quadrant. But here we need only first quadrant case. That's why I'm right here. See, theta is lies between 0 comma pi by 2. So we have showed that for theta lies between 0 to pi by 2, our function is said to be increasing function. Okay. This is our next question. Find the intervals in which the function f given by f of x equal to x square plus 2x minus 5 are strictly increasing or decreasing. Okay, so let's start the solution of this question. Given that function f of x equal to x square plus 2x minus 5. Okay, so first of all, we need to find the first derivative of our function, that is f dash of x equal to, we know that the derivative of x square is 2x and derivative of 2x is 2, that is 2 is a constant, derivative of x is 1. So 2, and derivative of 5 is a constant, so derivative of constant is equal to 0. So we get f dash of x equal to 2x plus 2. Next we need to find the interval. So next I am going to put f dash of x equal to 0, and f dash of x is we get 2x plus 2. So substituting here we get 2x plus 2 equal to 0. So 2x, and taking this plus 2 to RHS we get minus 2. From this x we get minus 1. Okay, so the point is x equal to minus 1. So this divides the real line into two intervals, that is minus infinity. Here the point that we get is minus 1, and this is plus infinity. So this x equal to minus 1 divides the real line into two intervals, that is minus infinity comma minus 1 and open interval minus 1 to infinity. So let us take first interval. Let us take one value between minus infinity to minus 1. Here I take x equal to minus 2 and put into f dash of x. We get f dash of minus 2. It is equal to minus 2. So we know that if f dash of x is less than 0, the function is called strictly decreasing. Strictly decreasing. So we get here, we get this function is decreasing in the interval minus infinity comma minus 1. Okay. Next let us consider next interval minus open interval minus 1 comma infinity, and let's take some values between minus 1 to infinity. I take x equal to 0 and I putting this x equal to 0 in f dash of x, we get 2 here, and which is greater than 0. If f dash of x is greater than 0, the function is strictly increasing. So here we get our function is strictly increasing in the interval minus 1 comma infinity. Okay, so it's a simple problem. I hope you understood.